Good morning. For attendance, let's practice partial fraction decomposition. It's one of the technique that we learned in chapter 6, and we haven't been doing it for a really long time. So we're gonna review how to do partial fraction. It is part of the study guide, and you probably saw the practice question on homework. So this is kind of like an additional practice. Do it yourself. I think you're able to figure out the answer. Anyone already have the answer? Situation. And when you don't have your clicker card, you don't have pen or paper. Okay, what happened to Monday? Answer, I can't see it. If you get how to do integration of the partial fraction decomposition, integrate go over. Basically, partial fraction decomposition is a method for integration. If you want to integrate a function that is a rational function, we do not have integration formula for this kind of question. So what our plan is to write it into two separate summation or subtraction of two functions. So we're hoping to rewrite this function. So we're gonna write it into a different format to make it possible to integrate. So actually, this is equal to, we're hoping to write it into a number divided by, you can see this denominator is factorable. The denominator x squared minus 3x minus 40 can be factored into multiplication of two factors. Do you know the factors? X minus 8, x minus 8, and x plus 5. Right, that kind of echo with some of the choices. You can see where those coming from. And then we write it into a smaller denominator. So we have a number over the x minus 8.
It's simply not D, that's for sure.
Right. So over b over x plus 5. So we're rewriting the function so that then the integration is easier. That's the partial fraction decomposition. It's not stopping the integration. It's changing the integration to a question that's slightly easier to calculate. That's right. So once you actually know the number a and b, you got the processes go from here, this step, go from here to here. That is partial fraction decomposition, rewriting the integration into something easier for calculation. And then each one of these can be calculated one by one. So for example, a over x minus 8, 1 over x minus 8 can be integrated into ln. So if we know the a, it's going to be a times ln x minus 8 x value x minus 8. So for 1 over x, we have the integration formula. Therefore, by substitution, we have for 1 over x minus 8, we also have the formula. The natural log function is an integration formula. So we have integration formula for this kind of format. We don't have it for this. That's why decomposition will be helpful for solving this question. So similarly, for the second summation part, we have plus b times ln of x plus 5. That was supposed to be f the value. F's the value of x plus 5, and then plus c. So that's pretty much the major format of the solution. The only thing left is we really have not solved a and b. So if we have a and b number, we'll be finishing up with the question. Essentially, we aim at rewriting this. So this is supposed to equal to a over x minus 8 plus. So rewriting this process is called partial fraction decomposition. So that's what we try to do, figure out a and b. Then your answer will be exactly in that format. This is the format of the answer if a and b is known. So in order to solve this is the equation. So if you're solving equation, you're making left side equal to right side. You can do a lot of algebra maneuver with the equation. So what we can do, we multiply both sides of the equation by the denominator. The denominator actually equal to, see, this one equal to this one. So that denominator is the same thing as over here. We multiply both sides of the equation by this, which is the same as this. That cancel the denominator. So after you multiply both sides of the equation by the x squared minus 3x minus 48, you will get 5x minus 1. We have 5x minus 1, which is equal to a times x plus 5, because x minus a will be canceled with the denominator, so they don't have to show up in the numerator. B times x plus 5 will cancel x plus 5, and then you have x minus 8 left because we're really multiplying the denominator, which is the equation. So now we can think about matching the coefficient. So a is the coefficient for x, and its coefficient a and b. So a plus b should be the 5, and then 5a plus minus ab is supposed to equal to the -1 if you match the coefficient. Then I normally would substitute with a number to answer this question, because in this case, matching coefficient of x and coefficient of number would cause you to have a linear system of equation to solve, and that's a little bit long process. So we're gonna make x equal to -5. That way, this is the equation. The equation is supposed to be true for all x values. So if x equal to -5, then x plus 5 is equal to 0, and the a would multiply by 0. So then you have 5 times -5 minus 1. On the left side is -26, and the right side is b times -13. Right, and that gives you the solution for b. So with that, we can see that b is equal to Right, and then similarly from that same equation, you can make, so then we're gonna scratch x equal to -5, we switch to a different x value, we make x equal to 8. Right, if x equal to 8, the right side is 40 minus 1, that's 39, so it's 39 equal to 8 times 13. Right, and that causes us to be able to solve for a, and a actually equal to 3. So now we can, we actually know the number for a and b, a equal to 3, equal to 2. Right, so the original answer will be clear after we have a and b value. So this is the whole process of, and figure out the right integration here. Edwin, you want to use your phone to scan your card?
No,
You don't have your phone?
I don't have it on my.
Oh, yeah, but I can find the image, on the speaker website, so you can, did it scan? Okay, so we can find out your card number, and I can show you your card. So it's card 18, I can find the card, and then you can use your phone to take image. Picture of the image is 18. Right, and you can copy the image and answer the question. Did you take the image?
Yeah.
All right, and you can see that was the answer. Do you remember the solution? It's 3 times logarithm x minus 8f's value plus 2 times logarithm x plus 5f's value. Let's see. So that will be. Okay. So we can. Let me record your attempts. Good. You made it brighter. Let's make it darker so we make the contrast readable. It won't work. Weird. Let me turn the direction. Maybe I stand in somewhere that's too bright. That's convenient. It used to work. I still will scan. I think it did at this time. So the answer is A, and that's today's attendance question. I hope this kind of reminded you, what was the process for partial fraction decomposition. Gage, are you online? It's A, so that you didn't change. All right. So make sure you check, these are, the final exam study guys, so this will be the focus of the question. I posted a question for you to practice your skill, and you try that question on Webwork, you can see if you are like up to date, without looking at the note, without review, the textbook, if you're able to solve the question on Webwork, you probably are like, know the majority of the steps. So, these are the first 3 questions are from chapter 6. These are the integration technique. We can do integration by part if you have multiplication of 2 separate types. Like one is logarithm, the other one's polynomial, or one is trigonometry, the other exponential. So when you multiply 2 separate types, different type of function, you may have to apply integration by part for in order to find the antiderivative. 6.3, the integration of trig function. is one of the focus because we're using the integration of trig function to solve other type of function. So integration or trigonometric function are the tools or the paths for a lot of other integration. The third one is integration using the partial fraction decomposition. That was just the one we practiced a moment ago. And then the rest of the next two questions are from chapter 7. We're using integration to solve volume question or area questions. These are the two that you may have to practice. And that was 7.4. Ignore the B. 7.4 was using integration to find length of the curve or using integration to find surface area. And then we have chapter 8. So I picked two questions from chapter 8. How do you calculate infinite sum? And the other one is how do you expand any function with Taylor series expansion? For chapter 9, we have equation of tangent line with parametric equation, equation of the polar curve. I think that's a little vague. Should be the transformation or identification of the curve pictures. And number 10 is how do we find the length of the polar curve or area within the polar curve. Those are the 10 questions that I think after studying how to, we should be able to answer. So any question? Yes.
I think I remember. Do you mind looking at number 6?
Of the 10?
Yes.
Section.
My number 6 looked very interesting. Like, what is that?
Okay, so you don't know how to, so maybe we didn't practice that kind of question enough. Let me see. For 10. Number 6, thank you. This one?
Yeah.
Okay, this is trying to use a infinite sum to represent what we used to practice. So we can use a infinite summation to represent repeated rational number. Because if you have a decimal number and this decimal number has no pattern, like 3.14526, you can't predict the next number, and that's what we call irrational. So irrational number cannot be represented by a division of rational numbers, division of integers, but any decimal number that has pattern or that has repeated decimal can be represented with a fraction. You can think of it as the summation of infinite many numbers. So maybe I can try explain this process. One of the application of infinite sum. I think it was in the textbook. Right. So essentially, we aim to try to figure out the true value of that fraction, that number. So what is this number? It's actually 6.6 plus we're adding plus 0.006. So that's handling this decimal, right? And then plus 0. Then you can see that one, which has 1, 2, 3, 4, 4 0. So you have 0, 0, 0, 0, 6. And then plus and the 6 after that is 0.0000006. So the number of 0, there's 2, there's 4, there's 6, and then there's 8. So that's a repeated decimal there. And you can find out how many the pattern there. So what we wanted to represent is using the geometric series to represent it. So the first one is, let me try to write, is equal to the first number stand alone, and then the other number. This is 6 times 10 to the power of -3, right? If you have the 6 isolated, that's 0.001. If you have 1 with 3 0 before, that's 10 to the -2 power. So we can see that similar pattern that you're writing this way, it's making it harder to see what it is. This is the 6 times 10 to the negative 3 plus 6 times 10 to the negative 5, and then plus 6 times 10 to the negative 7. All right, you can almost imagine the next one will be 6 times 10 to the negative 9. So we can see the pattern there. So this is a geometric series. We can see the initial term will be this one. And then the A would be 6 times 10 to the negative 3. Initial term is A, and then the common ratio is the one that you have to multiply in between, like this one to that one. You multiply 10 to the negative 2. That's causing it to raise by 2. And then this one to the next one, you multiply by 10 to the negative 2 as well. That's causing it to get smaller and smaller. So the ratio is exactly 10 to the negative 2. Or you can also write it as 0.01. That's how it gets smaller and smaller each time. So we're able to determine the summation of this entire thing. And that will be initial term for geometric series is initial term over 1 minus r, which then equal to A would be 6 times 10 to the negative 3. R is 0.01, so it's like a 1 minus 0.01. So then this is equal to the numerature essentially is this, right? Or this. So the numerature is 0.0066 with 3 0 before. Basically, if you got an integer with how many 0 before that number, that's negative power. Okay, and the denominator is 1 minus 0.01, and that's essentially a 0.99. Okay, so that can convert it to a fraction. You can have numerator denominator multiplied by 1,000, and then the fraction is actually 6 over 990. That was that fraction. And then over here, this one is a fraction. I find out the solution for this entire summation, right? Infinite term. And then that one is really 6.6 over 10. Like that. 66 over 10, right? Try to convert everything to a fraction. Yes. And then we're combining the decimal. Try to get it smaller so I can have space. So essentially it become one fraction that was 66 over 10 plus another fraction. This entire thing infinite many term. The total summation is 6 over 990. We're combining two fractions by summation. You find common. Maybe we can simplify them before we find common denominator. 990 can be the common denominator. So the numerator will be, this will just be 6. And that one you have to multiply by 99. That's 66 times 99. That will be the fraction. Okay, so we're looking for a two integer, P and Q. So this is P, this is Q. The Q would essentially be the 990, and the P would be whatever 66 times 99 plus. That's okay. Are we okay? Thank you. So that's this example. So we got 990, and then numerator. I gotta use a calculator. It's 66 times 9. Let's have a calculation error. I think it's because I didn't simplify the common factor. It says we wanna P and Q are positive integer, that's no common factor. So I guess I should actually look at the thing. Okay, so the denominator was 990 right now. And the numerature was 6,540. So we should cancel common factor before we create the answer. 654 over 99. They all looks like they're all multiple of 3, so we divide by 3. The denominator divided by 3 would be 33. The numerature divided by 3 would be 254 divided by 3. 1 and 8. So 2 and 8. Right now they were all, there's no more common factor. Yeah, so the 33 has 3 and 11. The 208 has 2. And definitely does not have 11 or 3, so that they have nothing in common. So the numerature should be 218. Denominator should be. I did not read the question carefully. It says no common factors. That was something that I overlooked. Any other questions? Any other homework question for the practice question sets? Try the rest of the question. I guess the other one, we at least we have seen them before in the homework assignment. And the number 6 was really new. This one is some of the figure that we see in the polar curve. You can graph them to match with the description. This will take a pair when r equals to theta. We know that spiral, right? That was a spiral. Whenever you have r equal to a function, theta is a spiral. This is r squared, x squared plus y squared equals 1 over 2. One over 2 sine theta cosine theta. I think it's hyperbola. This you can check. I think you can graph it. You graph every single one of them, and to double check what kind of picture it looks like. And this one definitely was spiral. Okay, I have to double check. First one should be, because it's r squared equal to 1 over 1. Cosecant theta is 1 over sine 2 theta. And sine 2 theta is 2 times sine times cosine. So that you have 2 times x over r and y over r. R goes back. This is the parabola. So there will be a h r equal to cotangent theta. There's basically 2 methods for the conversion. One is you convert it into xy equation, convert it to rectangular equation, and from there you can determine the shape. Or you pretty much graph the polar equation, identify the shape. I hope that helps. So, any question for this one? Have you guys tried it? Similar to some of the questions that we had in chapter 9. This was a 9.3 question. Any other questions? If you are online, do you have any question for the homework? I think people left after the previous question. Any question if you're online? This week we pretty much it is in review mode. As we mentioned that we won't have any additional new material. The whole class covered chapters 6, 7, and 8, 9. So we pretty much are going to review the stuff that we learned for. Questions? So since we got time and you guys have no question, let me try to go over the rest of these. Yeah. All right. So how do we identify these? The detail. So these are a couple of polar curve, and then here we have description of the polar curve, and we want to identify which curve match which description. Let's start with the first one. You first want to convert it to the one you can write x and y onto it. We have a cosecant, which is not in our polar rectangular conversion formula. Our conversion goes x equal to r times cosine theta. So whenever you see r times cosine, you immediately write a y value, y equal x value, y equal to r times sine theta. And then if you have x squared plus y squared equal to r squared. So if you see r squared, you can write this. Or if you have only the angle and has no r, see these two angle has to be combined with r to get x and y. If you don't have r, you only have the angle, then you have to rely on tangent theta equal to y over x. This is a way to convert angle into x and y. So from here, you can see that's the four familiar formula. But if we don't have any of these, we don't have r, we don't have cosine or sine, we don't have r squared, and then we have to convert it to something familiar. So cosecant is 1 over sine. This is actually r squared equal to 1 over sine 2 theta. And then sine 2 theta is double angle. Sine 2 theta equal to 2 times sine theta times cosine theta. Okay, and then we can multiply both sides of the equation to the multiply 2 times. Right now, this equation like this. We have r squared equal to 1 over 2 times sine theta, cosine theta. This is our polar equation. So you multiply both sides of the equation by the denominator, the 2 sine times cosine. And then you have 2 times r squared sine theta cosine theta that equal to 1. Okay, so that's algebra conversion. So far all the equations are equivalent, and then you can see this 2 times r times sine theta kind of break down the r squared, and it's r times cosine theta that equal to 1. So that is showing that we got 2. That was y. Okay, r times sine is y. 2 times y and times x, which equals 1. Okay, and then you write this into y equal to 1 over 2x. And then the picture of this will be showing a negative reciprocal relation between the two variables, meaning that if x is large, if x is small, y is large, which is here. Right? If x is big, the y is small, right? 1 divided by a big number, so it's over here. Okay, so picture y looks like this. It's not a line, it's a curve, the relation, but the contivity goes up. That's that part. For the negative part, has similar relation. That is a hyperbola, which have a separate portion. Are we okay with it being that? So that is a hyperbola. I guess that h, it kind of makes sense there. So that's the first polar curve, and the second. Any question? Right, the second polar curve, again, I would want to convert it to a rectangular equation, or you graph it. If you have one of those graphing calculator, you can try. Right, the second one, those r equal to negative cotangent theta. Right, this is equal, r is equal to negative tangent cosine theta over sine theta. And then I would recommend multiply both sides of the equation by the denominator, and you're going to have r times negative, which is the negative to the other side. So r times sine theta is equal to negative cosine theta. Right. What else? We will multiply both sides by r because I really want to make it equal x to the r. And then you can see what happened here. In this case, the negative r times cosine is negative x. The r times sine is y. And then the r there, this is y. So r there is root of x squared plus y squared. That doesn't look familiar to any of the curves. So it looks like x squared plus y squared. We square both sides of the equation. X squared plus y squared times y squared equal to, if you square, it's gonna be a positive x squared. If you square it, negative will go away. That's how it looks like. Um, how does a picture look like? I don't have a immediate visual image in my head. This is showing if x equal to 0, if x equal to 0, y equal to 0. So we see the origin. If x equal to 1, then 1 plus y squared times y squared will equal 1. So for x equal to 1, there are two y values we can solve. So up and down. So it's this way. That's for a positive x, and because x and y are both being squared, it's symmetrical, so it can be symmetrical on that side. I think that's the picture. I was using points like x equal to 0, x equal to 1, x equal to 2. You can try and look at other solution for this. For the anticipation, we can graph it with a quick equation r equal to negative tangent of theta. Oh. Cotangent theta. Equal to negative. Okay, so that's what it looks like. How do we name this? I think it was called airways. Yeah, so this is the one that has a picture that looks like a pair of wings. That would be the picture. That's the second full curve. Any question? That's that, and then this out. That's the second graph. It goes W wins. The third one has r squared equal to 19 sine theta. Weird. I remember the r equal to 19 sine theta, which is representing a circle of radius 19. So this is how this one looks like. Okay. They're not the same. If r squared equal to 19 sine theta, then if r squared equal to 19 sine theta, this has to be positive. For sine theta to be positive, you should have, again, only at the positive portion. So this is the r squared, so we have positive and negative. So should, if this r can only be positive, with that one. That's what I think it would be. We can convert this into rectangular equation. This is x squared plus y squared. Okay, and then this is 19. The sine theta, you remember y equal to r times sine theta. So sine theta actually equal to y divided by r. And then x squared plus y squared, we equal to 19. And we keep the y and try to replace r equal to root of x squared plus y squared. So that's the rectangular equation. In this case, the y value has to be positive picture. So look like this. Let me try to, I think, I try to visualize it in my head. This is the R, square. We will graph it if we do R square, theta. Sine theta. There's no graph. We have to take the square root of this, so, this equal to a circle, r equal to 19 sine theta. We studied this before. If we are equal to a single sine or single cosine with degree of 1, it's a circle. According to if it's a sine, it's a positive circle. Negative sine, it's a negative circle. If it's cosine, it's a right circle. If it's negative cosine, it's a left circle. So now we take square root of what we got. With the 19 sine theta. Right. Let's check the picture. That's this, and then r equal to negative square root of 19. Because we don't get to have the r square, so we have to do the positive and negative. And I think that's the picture for the r square equal to 19 sine theta. Kind of have to represent the positive portion and the negative portion for the r. So that's look like a cartoon image of a number 8. So then the visualization of this is the figure 8 picture. That one we knew is a spiral, and we talked about this before for r equals theta. Because as theta gets bigger and bigger, r gets bigger and bigger. That shows a spiral. Or any other function also, r equal to 2 theta, 3 theta, r equal to theta squared. It's also spiral, or r equal to 2 theta plus 1. It's also spiral. Any function of theta with no angle relation will cause the r to increase as theta increase e to the theta. These are scenario of different variety of spiral. So anyway, the last picture is r equal to sine 2 theta. That is something we might have seen before. The last one goes r equal to sine 2 theta. And I think we convert this on our test in test 4. So this is r equal to 2 times sine theta times cosine theta. Right, we can multiply just to make it convenient. We multiply r here to create an x and multiply r here to create a y, and then therefore we multiply r squared. Because both sides of the equation, if you multiply r on the other side, you multiply r on the other side. So left side and right side has to be balanced. So this ends up getting us 2y times x is equal to r cubed. Root of x squared plus y squared is r, and that's being cubed. So the image is when x and y equal to 0, x equal to 0, y has to equal to 0. So then that is the curve that goes to the origin. If x equal to 1, we have 2y equal to root of 1 plus y cubed, y squared cubed. Right, this will be equation. You can solve the y value. In this case, you get a y value here. If x equal to -1, then x equal, right, x equal 1. 1 for x, a positive value for y. We can use the equation solver to find the y. the y will be here. If x equal to -1, it will be -y, so then y will be here. So it would be a curve that look like a curve symmetrical about the origin. Shape would it be a circle or? I don't want to algebraically solve the equation because that will take more time. If x equal to 2, then we are solving this equation, root of 2 squared plus y squared cubed equal to 2 times y times 2. Yeah, we have to solve the equation. Let me try. If you want to actually find out the point, it's better to solve this equation. So let me see. Square root of 1 plus y squared. I feel like take a bit more time. To the power 3, which equal to to 2y. Solving this, all right. Solution. Okay, solution. Maybe I zoom out too much for us to see the solution. Okay. With 1. So that means this point is x equal to 1, y equal to 1. Okay. Second point, let's make it x equal to 2. It's a really slower way to graph it. One plus x squared to the power 3 2y. Let's do it. There's no solution. Right, and I think this is taking way too long. Let me just show you the picture. Graphing it point by point. This is r equal to sine 2 theta. Oh, that's the one that we actually talked about it. I should know this. Anyway, so this is one of these images that I probably don't want to write the rectangular equation for, which I did. This is a rectangular equation. It doesn't really show any of the information that we want to identify. So the pole equation is really straightforward. It was a 4-pattern rules because it has a sign of a even power. I think it was doing this with you guys together in class. Whenever there's a even number of theta inside the sign or cosine, we see multiple pattern rules. Really, I really don't remember. Totally block out that information. This is one of these situations when the polar curve is more versatile than the rectangular equation. The rectangular equation that we converting it to is more difficult to graph or difficult to study, and then I try to graph it point by point, which takes a lot of time, and there's a lot of situations the equation itself doesn't even have a numerical solution. But when the theta is 2, sorry, and today my brain is really not working. It's a 4-petal rose. You can see a rose with 4 petals. That was hard. Felt like I should replace this question, maybe use another equation from 9.3, because that was not a typical question. That it would be a lot easier if we had experience graphing each one of these. So if you graph it all, then the graph kind of shows, especially the last one, the graph is the one we can match with the equation itself. But using the polar equation to connect with the graph is a lot easier than using the rectangular equation that we find out. So the rectangular equation doesn't serve the name that well, the name of the image. But polar curve does have its importance, but maybe I'll focus on the conversion more than the name of the graph. So I'll definitely try to switch that question out for a 9.3 question. Our study guide plan is to review polar curve as a polar equation. I think I picked the wrong question for a sample. All right, the number 8 question, number 9 question is supposed to be a polar equation of polar curve. It was one of the 9.4 question. Let's pick the 9.4 question that matches our skill, the one that we actually practice a lot. In 9.4, we practice polar coordinates and polar equation. So let's pick one of the homework questions as our practice instead of using that one. There are a couple of questions that we did study. The shape in 9.4, but not the name of the curve. Trying to look through these. Okay, so let's use question 10 or 9 or that was okay. Or 6, 5, that kind of question. So let's try to, I'm probably gonna substitute the number 8 question with a slightly easier question. So you can see, even I forget some of the names or shapes of the picture. There are a lot of polar curves, so it's hard to exhaust them in our study. Question 8 on the practice. The rest of them looks like these are some of the questions we did on the test and also on homework. This question is the one we just did. I'm probably gonna replace it with more of a homework question from chapter section 9.4. This is the question that we did practice in 9.3. This is a 8.7 question for the Taylor expansion. That one we just did it together with the geometric series. Area of the curve. That was a 7.5 question. Region bound, calculating volume of revolution. This is the one that is a weaker link in our study in chapter 7. So try to go over this question. We did a practice on paper station. For number 2 is the trigonometric integration. Do you have any questions for this? Do you know how to integrate tangent to the first power? Do you know how to integrate this? Okay, or to secant square. And then substitution, we think we can solve this with substitution, right? Right? Okay. Happen on the- So that was chapter 6 for the trig integration. Trying to choose one of the chapter 6 questions. This one. Right, let's try this one. It's a trig integration with cosine cube. Remember, this one can be solved with substitution. So integration sine power, cosine power, tangent power, secant power are some of the common question. If you have cotangent or cosecant, probably we can try, their relation is similar to the relation with secant and secant. You're stuck with some of the trig problem, you can always convert them into sine and cosine to solve it. So basically, the two fundamental function in trig sets is sine and cosine. All the other trig can be converted to sine and cosine. Do we know how to integrate this question? Let's do a use substitution. And this will be the last question for today. In the meantime, let me remind you, if you haven't done the course evaluation every semester by the end of semester, we are sending, I think, every student get email for the course evaluation. So please try to fill out your opinion or advice or feedback on how the semester has been run. If you have any suggestions or complaints, I will to mention that in your course evaluation. It's very important for us to have a lot of data, a lot of feedback from students. And try to fill out the evaluation form. I think it was under course resource. There's student evaluation, at least on my Georgia presentation have similar things. Or you can find it in your email. Every student received email for the evaluation link. So make sure you did for your opinion for all the courses that you taking. To that question. Please remember to fill the evaluation. All right, like I said, this is a cosine with odd power. Sine or cosine, if it's odd power, you can always substitution. If it's even power, we'll have to do power reduction. So this question, we don't have to do power reduction because it's an even power. We can take off a 1 power for substitution. So the plan will be writing it this way. You have 7 cosine square for x, and then there was a cosine odd power, so you take a cosine force power, a cosine for x to the side. Okay. So why do we take 1 aside? Because that could be the du. Okay, so that combined with dx, that's the whole point of the substitution method. So what we're gonna do, we're actually gonna go u equal to sine of 4x. If you have u equal to sine 4x, then du would equal to cosine 4x times 4 times dx. Because of changeable, right? So because of this, then you can see the one you have right there is this cosine 4x dx. Already have there, and that is going to be 1 force du. So 1 force du is how you write this part. That's substitution, right? We write in substitution. So what happened to the other part, this part? The cosine square equal to cosine square of 4x plus sine square 4x will equal to 1. 4x equal to 1. So that means cosine square 4x square 4x will equal to 1 minus sine square 4x. What's sine square 4x? It was u, right? So that's 1 minus u squared. So over here, this part is going to be 7 times 1 minus u squared, and then integration. So that's how we can convert it to a integration with u variable. And that's why it works out as substitution method. So we're going to go ahead and integrate this part. It's equal to 7 over 4 integration 1 minus u squared du. So you can see we're able to simplify the integration after the substitution. That's why substitution works. Whenever we have a odd power, we'll take 1 away and ready for the substitution of the variable. So integration this one, you get 7 over 4 u minus u to the cube power over 3. That was the integration part, and then plus c. And then remember what happened to u. U equal to sine to the 4th x. So it's 7 over 4 sine 4x minus 7 over 4 times 3. 7 over 12, and then sine to the cube power 4x. So that's what it is. You have to rewrite a u into sine 4x to have your final answer. I hope that's clear enough what was the answer now. Are we okay? So let me record your answer to this question. I hope that you're able to follow with the substitution method. This is once again one of the situations where it looks like one of those time-consuming questions, but it's not the substitution. The answer is not too far from your anticipated answer. So the one is 7 over 4 sine to the 4x, and then with minus 7 over 12 sine cube 4x. Right. Okay. Thank you, everybody. We submitted, and this is what we have submitted. Yes.
Didn't realize that.
Okay, yeah, this is the calculation that we covered from here after substitution, we integrate, and then the u equals sine 4x. So you really are getting a polynomial with sine 4x. You want to submit your answer?
Not yet, I'm still working it out.
Okay. But that was the calculation process. All right, about next Monday, this is a class, well, we also have Tuesday, right? So it's a little too early to talk about next Monday. So my plan was next Monday is, right after Thanksgiving, and that week was us getting ready for the final exam. So, we're gonna have regular class today and tomorrow. Next Monday, we can make it optional. Is that okay? That way you can have whatever plan you had or how you wanna prepare for the final exam. We can make next Monday a little bit more flexible, but you're welcome to come by with any question or concerns over the, set of grades or over the, or any past tests. Feel free to let me know if you wanna make up any past test. If you feel like one of the tests is lower than expected, then you can retake some of the past tests to bring up your grades. That should be everyone. Emmanuel, are you still online? Right, this will be the last question for today, and basically, we're pretty much reviewing everything. Finish any remaining homework. If you want to retake your test, let me know. We can schedule. I'll send the test to the testing center. Next Monday is optional, but I'm still gonna be here for the class session. But if you guys have plans for how you want to prepare for the final exam, it's okay to skip next Monday. But I'm hoping that before Thanksgiving, we're still in a study mode of the. Okay, so that's the plan. I'll see you tomorrow. Thank you. Switch the final exam questions for a different version of that one. Like the question 9. Out of the one. Remove it.